हेलो एवरीवन। आज का लेसन रहेगा हमारा ज्योग्राफी चैप्टर नंबर 8 सोलर रेडिएशन हीट बैलेंस एंड टेम्परेचर। डू यू फील एयर अराउंड यू? डू you know that we live at the bottom of a huge pile of air? In we inhale and exhale, but we feel the air when it is in motion. It means air in motion is wind. You have already learned about the fact that Earth is surrounded by air all around. This envelope of air is atmosphere, which is composed of numerous gases. These gases support life over the Earth's surface. The Earth receives almost all of its energy from the sun. The Earth in turn radiates back to space the energy received from the sun. As a result, the Earth neither warms up nor does it get cooled over a period of time. Thus, the amount of heat received by different parts of the Earth is not the same. The variation causes pressure difference in the atmosphere. This leads to transfer of heat from one origin to other by winds. This chapter explains the process of heating and cooling of the atmosphere and the resultant temperature distribution over the Earth's surface. First step, solar radiation. The Earth's surface receives most of its energy in short wavelength. The energy received by the Earth is known as incoming solar radiation, which in short is termed as insolation. As the Earth is a geoid resembling a sphere, the sun's rays falls obliquely at the top of the atmosphere, and the Earth inter intercept a very small portion of the sun energy. On an average, the Earth receives 1.94 calories per square centimeter per minute at the top of its atmosphere. The solar output received at the top of the atmosphere varies slightly in a year due to the variation in the distance between the Earth and the Sun. During its revolution around the Sun, the Earth is farthest from the Sun 152 million kilometers on 4th of July. This position of Earth is called aphelion. It means the aphelion in 4th of July is called of the revolution around the Sun and the farthest point of the Sun. On 3rd of January, the Earth is nearest to the Sun 147 million kilometers. This position is called perihelion. Perihelion nearby, aphelion farthest. Therefore, the annual insolation received by the Earth on 3rd of January is slightly more than the amount received on 4th of July. However, the effect of this variation in the solar output is masked by other factors like the distribution of land and sea and the atmospheric circulation. Hence, this variation in the solar output does not have great effect on daily weather chances on the surface of the earth. Variability of insolation at the surface of the earth. The amount and the intensity of insolation vary during a day, in a season, and in a year. The factors that cause these variation in insolation are first, the rotation of Earth on its axis. Second, the angle of inclination of the sun's rays. And the third, the length of the day. And fourth, the transparency of atmosphere. And fifth, the configuration of land in terms of its aspect. The last two, however, have less influence. The fact that the Earth's axis make an angle of 66 and a half with the plane of its orbit around the Sun has a greater influence on the amount of the insolation received at different latitudes. The second factor that determines that the amount of insolation received is the angle of inclination of the rays. This depends on the latitude of a place. The higher the latitude, the less is the angle they make with the surface of the earth, resulting in slant sun rays. The area covered by vertical rays is always less than the slant rays. If more area is covered, the energy gets distributed and the net energy received per unit area decreases. It means if more area is covered, the energy gets distributed and the net energy received per unit area decreases. Moreover, the slant rays are required to pass through greater depth of the atmosphere, resulting in more absorption, scattering, and diffusion. So, most of the part in depth, absorption, scattering, and diffusion. The passage of solar radiation through the atmosphere. The atmosphere is largely transparent to short wave solar radiation. The incoming solar radiation passes through the atmosphere before striking the Earth's surface. Within the troposphere, water vapor, ozone, and the other gases absorb much of the near infra radiation. Very small suspended particles in the troposphere scatter visible spectrum both to the space and towards the Earth's surface. This process adds color to sky. The red color of the rising and the setting sun setting sun, the blue color of sky are the result of scattering of light within the atmosphere. Spectral distribution of insolation at the Earth's surface. The insolation received at the surface varies from about 320 watt per meter square in the tropics to about 70 watt meter per square in the poles. In tropic areas, 320 watt per square and in poles areas 70 watt per square. Maximum maximum insolation is received over the subtropical desert where the cloudiness is the least. Equator receive comparatively less insolation than the tropics. Okay. Equator receive comparatively less insolation than the tropics. Generally, at the same latitude, the Insolation is more over the continent than over the ocean. In winter, the middle and higher latitude receive less radiation than in summer. Heating and cooling of atmosphere. Heating and cooling of atmosphere. There are different waves of heating and cooling of atmosphere. The earth after being heated by insolation transmits the heat to the atmospheric layers near to the earth in long wave form. The air in contact with the land gets heated slowly, and the upper layer in contact with the lower layer also get heated. Okay, this process is called conduction. It means air in connect with the land gets heated slowly, and the upper layer in contact with the lower layer also heated. Okay, this process called conduction. Conduction take place when two bodies of unequal temperature are in contact with one another. There is a flow of energy from the warmer to cooler body. The transfer of heat continues until both the bodies attain the same temperature or the contact is broken. Conduction is important in heating the lower layer of the atmosphere. The air in contact with the air rises vertically on heating in the form of currents and and further transmit the heat of the atmosphere. This process of vertical heating of the atmosphere is known as convection. Okay. The connective transfer of energy is confined only to the troposphere. The transfer of heat through horizontal movements of air is called advection. It means horizontal, then called advection. Horizontal movements of the air is relatively more important than the vertical movements. In middle latitude, in middle latitude, most of diurnal day and night variation in daily weather are caused by advection alone. In tropical regions, particularly in northern India during summer season, local wind called blue is the outcome of advection process. Terrestrial radiation. The insolation received by the Earth is in short wave form and heats up its surface. The Earth, after being heated itself, became a radiating body, and it radiates energy to the atmosphere in long wave form. This energy heats up, heats up the atmosphere from below. This process is known as terrestrial radiation. The long wave radiation is observed by the atmospheric gases, particularly by carbon dioxide and the other greenhouse gases. Thus, the atmosphere is indirectly heated by the Earth radiation. The atmosphere in turn radiates and the transmits heat to the space. Finally, the amount of heat received from the sun is returned to space, thereby maintaining constant temperature at the Earth's surface and in the atmosphere. Heat budget of the planet Earth. Figure 9.2 depicts the heat budget of the planet Earth. The Earth as a whole does not accumulate or lose heat. The Earth as a whole does not accumulate or lose heat. It maintains its temperature. This can happen only if the amount of heat received in the form of insolation equals the amount lost by the Earth through terrestrial radiation. Consider that the insolation received at the top of the atmosphere is 100%. While passing through the atmosphere, some amount of energy is reflected, scattered, and absorbed. Only the remaining part reach reach the Earth's surface. Roughly 3-5 units are reflected back to space even before reaching the Earth's surface. Of these, 27 units are reflected back from the top of the clouds and 2 units from the snow and ice covered area of the Earth. The reflected amount of the radiation is called albedo of the Earth. The remaining 65 units are observed, 14 units within the atmosphere and 51 units by the Earth's surface. The Earth radiates back 51 units in the form of terrestrial radiation. Of these, radi- uh, 17 units are radiated to space directly, and the remaining 34 units are observed by the atmosphere. 6 units observed directly by the atmosphere, 9 units through convection and turbulence, and 19 units through latent heat of condensation. 48 units observed by the atmosphere, 14 units from insolation, plus 34 units from the terrestrial radiation are also radiating back into space. Thus, the total radiation returning from the Earth and the atmosphere, respectively, is 17 plus 48 is equal to 65 unit, which balance the total of 65 unit received from the Sun. This is termed the heat budget or heat balance of the Earth. This explains why the Earth neither warms up nor cools down despite the huge transfer of heat that takes place. Next, variation in the net heat budget at the Earth's surface. As explained earlier, there are variation in the amount of radiation received at the Earth's surface. Some part of the Earth has surplus radiation balance while the other part has deficit. Deflect. Figure 8.3 depicts the latitudinal variation in the net radiation balance of the Earth, the atmosphere system. The figure shows that there is a surplus of net radiation. balance between 40-degree north and south, and the region near the pole have a deficit. The surplus heat energy from the tropic is ready, redistributed polewards, and as a result, the tropics do not get progressively heated up due to the accumulation of excess heat, or the high latitude get perma, uh, permanently frozen due to excess deficit. Temperature. The interaction of insolation with the atmosphere and the Earth's surface creates heat, which is measured in the term of temperature. While heat represents the molecular movements of par- particles comparing a substance, the temperature is the measurement in degree of how hot or cold a thing or a place. Factor controlling temperature distribution. The atmosphere of air at any place is influenced by first the latitude of place, second the altitude of place, and third distance from the sea, the air mass circulation, and fourth the pressure of warm and cool ocean current, and fifth is local aspects. First, the latitudes. The temperature of a place depends on the insolation received. It has been explained earlier that the insolation varies according to the latitude, hence, the temperature also varies accordingly. And the latitude, the atmosphere is indirectly heated by terrestrial radiation from below. Therefore, the places near the sea level record the higher temperature than the places situated a higher elevation. In other words, the temperature generally decreases with the increasing height. The rate of decrease of the temperature with height is termed as the normal lapse rate. It is 6.5 crore per thousand meter distance from the sea. Another factor that the influence the temperature is the location of place with respect to the sea. Compared to land, the sea gets heated slowly and loses heat slowly. Land heats up and cools down quickly. Therefore, variation in temperature over the sea is less compared to the land. The place situated near the sea come under the moderating influence of the sea, and land breeze with moderate the temperature. Air mass and ocean current. Like the land and sea breeze, the passage of air mass also affected the temperature. The place which come under the influence of warm air masses experience higher temperature, and the place that come under the influence of the cold air mass experience low temperature. It means influence of warm air, then higher temperature, influence of the cool air masses, then low temperature. Similarly, the places located on the coastal areas where the warm ocean current flow record higher temperature than the place located on the coast where the cold current flow. Yes. Distribution of temperature. The global distribution of temperature can well be understood by studying the temperature distribution in January and July. The temperature distribution in is generally slowed down on the map with the help of isotherms. The isotherms are lining joining places having equal temperature. Isotherms. Figure A and B show the distribution of surface air temperature in the month of January and July. This this figure. In general, the effect of the latitude on temperature is well pronounced on the map, as the isotherms are generally parallel to the latitude. The deviation from this general trend is more pronounced in January than in July, especially in the northern hemisphere. In the northern hemisphere, the land surface areas is much larger than in the southern hemisphere. Hence, the effect of the landmass and the ocean current are well pronounced. In January, the isotherms deviate to the north over the ocean and to the south over the continent. This can be seen on the Earth Atlantic Ocean, the presence of warm ocean current, Gulf Stream, and the North Atlantic Drift make the North Atlantic Ocean warmer, and the isotherms bend towards the north. Over the land, the temperature decreases sharply, and the isotherms bend towards the south in Europe. Okay. It is much pronounced in the Siberian plain. The mean January temperature along 60 eastern longitude is minus 20 degrees Celsius both at the 80th of north and 50th north latitude. The mean monthly temperature for January is over 27 degrees Celsius. In equatorial oceans over 24 degrees Celsius, in the tropic and 2 degrees Celsius to 0 degrees Celsius in the middle latitudes, and minus 18 degrees Celsius to minus 48 degrees Celsius in Eurasian continental interior. The effect of the ocean is well pronounced in the southern hemisphere. Here the isotherms are more or less parallel to the latitude, and the variation in the temperature is more gradual than in the northern hemisphere. The isotherms of 20 degree, 10 degree, 0 degree runs parallel to 35 degree south, 45 south, 60 south latitude respectively. In July, the insolation The isotherms generally run parallel to the latitude. The equatorial ocean record warmer temperature more than 27 degrees Celsius. This parallel to the equator or latitude. Over the land, more than 30 degrees Celsius is noticed in the subtropical continent region of Asia. Along the 30 north latitude, along the 40 north runs the isotherms of 10 degree and along the 40 degrees south that the temperature in 10 degrees Celsius. It means 40 degree north and 40 degree south also same temperature 10 degree. Figure 8.5 shows the range of the temperature between January and July. The highest range of temperature is more than 60 degrees Celsius over the northern eastern part of Eurasian continent. This is due to continentality. The least range of temperature, 3 degrees Celsius, is found between 20 degrees south and 15 degrees north. Inversion of temperature. Normally, temperature decreases with increase in elevation. Yeah. It is called normal lapse rate. It means जैसे कि हमारा जो भी टेम्परेचर है वो एलिवेशन यानी ऊपर अगर बढ़ता है तो उसका टेम्परेचर कम होता जाता है. At at times the situations is resolved and the normal lapse rate is inverted. It is called inversion of temperature. It means the normal lapse rate is inverted. इसका उल्टा हो जाता है इसी को हम inversion बोलते हैं. Inversion is usually of short duration but quite common nonetheless. A long winter night with clear skies and still air is ideal situation for the inversion. The heat of the day is radiating off during the night and by early morning hours the earth is cooler than the air above. Over polar areas temperature inversion is normal throughout the year. Surface inversion promotes stability in the lower layers of the temperature. Smoke and dust particles get collected beneath the inversion layer and spread horizontally to fill the lower strata of the atmosphere. Dense fogs in mornings are common occurrences, especially during winter season. This inversion commonly lasts for few hours until the sun comes up and begins to warm the earth. The inversion takes place in hills and mountains due to air drainage. Cold air at the hills and mountains produced during night flows under the influence of gravity being heavy and dense. The cold air acts almost like water and moves down the slope of pile up deeply in the pockets and valley bottom with warm air above. This is called air drainage. It protects planets from frost damage. Planck's law states that hotter a body, the more energy it will be radiate and shorter the wavelength of that radiation. Specific heat is the energy needed to rise the temperature of 1 gram of substance by 1 Celsius. Thank you.